Hey everyone, welcome back to another video by Cam Room 5. Sorry I had to take a small break because all the exams and extra classes. So, returning to the experimental chemistry playlist, we're going to be talking about mixture and separation techniques in this video. But this video can also be useful as one of the very basic topics of chemistry, which is matter, anything that has mass and occupies volume. Matter could be pure or impure. Now, pure matter includes two kinds of substances, which is element and a compound, while impure includes solutions and suspensions. An element is a substance which contains the same kind of atoms. There are no two different kinds of atoms. All of the atoms are exactly same. They have the same proton number. When we talk about compounds, compounds can have two or more than two different kind of elements, which means different kind of atoms, chemically combined together. So there's a specific kind of ratio, a very specific kind of chemical bonding behind the combination of these elements to make a specific compound. Solutions and suspensions are kinds of mixtures, so they are not pure substances. It may be a mixture of two or more than two substances, like it could be an element, it could be an element or a compound and compound, and there's no specific ratio out there. They're not chemically combined, so there's no specific ratio. It may be a 2:3 ratio, it may be a 2:3.5 ratio. It is very vague. It is a spectrum of ratios that can exist. There's no chemical formula, that is why, because there's no ratio. Now, returning to elements, elements have the same kind of atoms over there. And the identity of atom is the proton number. So all the atoms present in the element have the same proton number. All the atoms have exactly the same number of protons inside their nuclei. And this is what the identity of atoms is. Even in the periodic table is based on the atomic number. Elements could be monoatomic, which means all the atoms are there. They are the same kind of atoms indeed, but they are not chemically bonded to each other. They are individual atoms. They are discrete atoms. This may be because they have a complete outermost shell and they don't want to bond. That is why individual atoms not chemically combined with other atoms. They contains complete outer shell. That is why they did not want to bond. For example, we are talking largely about group 8 or group 0. So you can call it group 0 or group 8. Group 0 because they have a zero valency. They don't want to react. Like helium from group 8 or argon, they have complete outer shells. Diatomic element, we are talking about elements again. Diatomic elements means two atoms of the same element, obviously. They are chemically combined together. So two atoms of the same element chemically combined together. So it's a pair of atoms and there is a chemical bond between those two atoms. It could be two bonds, it could be one bond, it could be three bonds. It generally exists between non-metal atoms which do covalent bonding. For example, when we talk about group 5, group 6, let me correct it. Yeah, so we're talking about group 5, which have 5 electrons in the outer shell, group 6, group 7. Like hydrogen from group 1 makes one bond between two atoms, chlorine from group 7, oxygen from group 6. They exist as diatomic molecules. When we talk about giant covalent element, it's a large number of atoms of the same element. We are again talking about the same element because they are the same atoms, but we are calling it giant because it's a huge number. So a large number of atoms of the same element chemically combined by a large number of very strong covalent bonds. So these strong covalent bonds are there which help in keeping all the atoms together. For example, you have so many atoms of carbon, for example, over here, and it makes a tetrahedral kind of structure by making bonds between the other atoms. This is the structure of diamond. So diamond is not a compound, it's an element, because all the atoms belong to the same kind of element, which is carbon. So carbon atoms join together through strong covalent bonds. It's not just like, let me label it. It's a very strong kind of covalent bond, which is obviously the sharing of electrons. If you have watched the playlist on bondings, you would know that. Another possibility is silicon, which is again a group 4 element. Silicon atoms are there. I made them larger because, down the group, the atomic size increases. Silicon atoms are bigger than carbon. But they are again bonding in a similar way because they belong to the same group. And they have again 4 covalent bonds by each silicon atom. So it's again a giant covalent structure, and it's a giant covalent element because all these silicon atoms are here. There's no other kind of atom. Now let's talk a little about the compounds. Compounds are made when 2 or more elements chemically combined with each other. So for example, there are 2 elements or 3 elements combining in a specific ratio. So it's a fixed ratio. We know every time how much hydrogen combines with how much oxygen, or how much carbon combines with how much sulfur. We know these specific moles, we know these specific grams, we know the specific volumes. It's not gonna trespass, it's not gonna violate those specific fixed ratios. They have very clearly defined fixed chemical and physical properties. Just a quick hint on what physical properties are. They have a very fixed melting point, boiling point. You can say density, which is the mass per unit volume. Their color is very much fixed every time water has a similar chemical and physical properties. Chemical properties include their reactions with acids, their reactions with bases, their reaction with maybe reducing and oxidizing agents and stuff like the redox reactions. So these are chemical properties. Mixtures, on the other hand, is made when 2 or more substances, are mixed together, basically. So you can say, okay, they're not combined in a fixed ratio. They're not chemically combined at all. They're just mixed together. They were 2 different pure substances or 3 different pure substances, and now they have been mixed together. So that is why they don't have a chemical formula. You can't have a chemical formula for salt water. There's a chemical formula for salt, there's a chemical formula for water. But there's no chemical formula for salt water because it's not a chemically combined fixed ratio. Their physical properties, their chemical properties are not fixed. They may have a different melting point. Each time salt water has a slightly different melting point. It depends on how much salt and how much water is there. Their densities are different, their solubilities are different. So we have 2 components in each mixture. One is solute and another is solvent. Solute is the one which is present in smaller quantity. We have this misconception that solute is always the solid. No. Solute is the component which is present in smaller amount, and the solvent is the one which is present in bigger amount. So, for example, in gaseous mixtures, there is no solid, but still there's a concept of solute solvent. You can see different kind of mixtures over here. On the left, you can see pure elements which have been mixed together. The red diatomic, the green diatomic, the blue diatomic. It somehow represents air or a mixture of gases, maybe oxygen, hydrogen, nitrogen molecules, diatomic ones. In the middle, you can see a compound with blue and red dots in a fixed ratio, and then green and red dots in a fixed ratio. Maybe it's HCl and water. On the right, you can see alloy, which is mixture of metals with other metals or non-metals. So these are solid metal particles with another kind of metallic element particles. So this is how mixtures are made. I hope this video is clear to us. In the coming video, we'll talk more about it. Stay tuned, guys. Thanks.